Okay, so this is chapter 3. So we are going to look at some numbers. If you are given a data set. So first of all, we will look at methods of central tendency. That means we are going to find, uh, some numbers which tell about the position of our data sets and some distributions of the data set in terms of the numbers. Okay. So before going to uh, see that, let's look at these two definitions. First, let's look at the meaning of statistic. A statistic is just a characteristic or a number which obtained by using the samples. So there are two things actually. So suppose if you are given the data set. So if you consider all of the data set in one picture, right? Say you have plenty of data sets, say x1, x2, and say you have n of them. Okay, so if you consider all the data values, that collection is called the population. Okay, so the population means what? It contains all the possible data values. Okay, so in this case, I have the number of data values. That is simply begin. Okay. Suppose if I want to consider only few of them, say I'm collecting, some parts of, those data values, right? So if you extract the small, portion of the population, which is called the sample, okay? Say suppose I have, some values about the samples, so you may have, say little n of them, okay? So the number of data values here in the sample, say little n. So these are the two, things we need to look at. Okay. So what is the meaning of statistics then? Statistics is we are calculating some numbers, measures which are coming from where? Which is coming from sample, right? From the sample we calculate or we find these statistics. Just a measure. So we will look at those measures now. So here, whatever you find, those measures are called the population masses measures, which is a parameter. Okay. Basically, parameter is a measure which is coming from the population, and the statistic is a measure which is coming from your sample. Okay, right. So now there are three, the measures now we are going to look at. Okay, um, the first one is the mean. Mean means simply the average value of your data set. Okay, how do you find the average? Of course, we all know. Suppose if we are given, say, 10 numbers, how do you find the average of those 10 numbers? Simply you will add all the numbers and divide by 10, right? So exactly the same thing here, the definition of mean says. So the mean, the sample mean, we use x bar, x bar. So x bar means this is nothing but sample mean. Okay, that means what? That means you are simply finding the average from the sample data values. So look at my picture here. So let me change the color. So if you look at here, so this is my sample, right? So here I will calculate my x bar, right? The sample mean. Okay. What is the formula then for the sample mean? So x bar is given by simply you add all the data values. So I have n of them, little n of them, then divide by number of data. They are in data values. Therefore, I'm dividing by n. In notation wise, we write this as, you know, kind of this notation times of x over n. what's the meaning of this? This notation is nothing but the Greek letter, right? So this is the Greek letter, uppercase letter. We call this as sigma. So this is a Greek letter, uppercase letter. Okay, uppercase. So the meaning of this notation is simply the summation or the total value of x. So this the meaning of summation x means the total value of all the data values. So sum of all data values, which is denoted by sigma x or sum x. So I am adding all the data value and dividing by n in notation wise. Okay. That means it is understandable that if I write like that, the meaning is that you are adding all the data values. That means I'm adding all the data values from my sample, right, all the way up to xn, then divide by n. So this is the meaning of sample name. Okay. So now we have a rule to oh, there's a typo here. So this should be a little n. Okay, not big n. It is little n. Okay, so let me go back and change my color. Okay, so now the rounding rule. The rounding rule says what? Suppose if you are given all the data values in the whole number, that means you have to round up your mean to one decimal place, one more decimal place than your data values. Okay. For example, look at this problem. This is the given data set. Okay, if you look at all the data values, all the numbers are whole numbers, right? The whole numbers means what? Whole numbers means 0 decimal place, right? Since these numbers are 0 decimal place, your x bar should be 1 decimal place answer. That is why if you look at the answer, you have 1 decimal place answer. Okay, so the notation says that the sample mean is summation x over n. So simply you are adding all the data values, right? And all the data values and divide by number of data values. How many data values are given? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 data values. Therefore, little n is 9 in this case. So simply I am adding all the values and divide by 9. So take your calculator and this notation is approximation, rounding up to 1 decimal place. Okay, so make sure that you are writing in 1 decimal place. So that is basically the sample mean x bar. Okay. Okay, good. Now, what will happen if we are given, the frequency table, group frequency table? Remember, in previous problem, the data set is just a raw data, right? You don't have, the table. But now, if you are given a table, then we have a different procedure to find the sample mean. What is that? First of all, you need to make a table. So, how many columns are there? You need to make 1, 2, 3, 4, 4 columns. Okay. You need to make 4 columns. Okay, first column is always will be given my class boundary column. The second one is the frequency. Now these two guys you need to find out. So in last section we we learned how to find the midpoints of the given class. Simply you will find the average of those two values, right? Upper limit and lower limit, or upper class boundary and lower class boundary. Divide by 2, so it will be midpoint. Then find that one. After that, you need to multiply, take the product of the frequency and your midpoint. Then make these 4 columns. Okay. So once you have all those 4 columns, the x bar is given by the sample mean is given by what? The summation of the product of fn xm, then divide by the number of data values, right? So in this case, if you are given a frequency table, remember you saw this last time, right? The number of data values is nothing but the summation of your frequency column, right? If you add all the frequency values, you will get total number of data values, which is my small n, right? Okay, so that is a small n, right? Actually, that is the summation of f. This is m. So this is the formula I'm going to use for group frequency table to find the sample mean. We will look at one example. Okay, look at this example. You are given a frequency, grouped frequency distribution table. So the first column is class boundary, second one is frequency. So you need to add two more columns, right? You see? So you need to find now midpoint and the product of the frequency and midpoint. Okay, so let me explain for a couple of the groups. The first one, I'm going to find the midpoint of the first class, right? Midpoint means simply find the average of those two numbers. So simply you add both numbers. So 15.5 plus 20.5, then divide by 2. Okay, so simplify this number. If you use the calculator, so you need to put the parentheses and type all at a time. This is 20.5. Okay, so 15.5 plus 20.5 should be 36. 36 divided by 2 is 18. So this is simply 18. So if you do for the second one, simply add 20.5 and 25.5. So when you add those two, so you will get what? So I'm writing only answer right away. So 20.5 plus 25.5 is 46, right? 46 divided by 2 is 23. So the second one is 23. If you do correctly, third one should be 28. Because why? Because the class width is 5. So you have to keep on adding 5. So if you do correctly, you should get 33 here and a 38 here, right? These all my midpoints. So once you have the midpoints values, simply multiply the midpoint value with the corresponding, frequencies. So I use the little f for frequency, right? So this is frequency. So I'm simply multiplying frequency with the midpoint, then you will get f times xm. So for my first group, my first class, my frequency is 13 and my midpoint is 18. So simply multiply 13 times 18. What is that? 13 times 18. So it should be 54 or 5 remaining, right? So 18 plus 5, it should be 23, 234. Okay, 234. So now, what is next one? 23 times 6. Take your calculator and multiply. So it should be 138, right? So 4 times 28, 112. 1 times 33, which is 33. And 1 times 38, which is 38. Okay, simply I am multiplying all the, the values. Okay, so I'm going to use the notation here, Akshut. So if you add all the frequency summation f, right, in notation wise, so simply that is 25. That means what? That means the total number of data values is now 25, right? So what's the meaning of this 13? There are 13 data values which fall between 15.5 to 20.5 and so on. So if we add all the frequencies, you will get the total number of data values, okay? That is my frequency column. If we add all the total from this column, right, that means the total of what? F times xm. Simply add these numbers. Check your calculator and add these numbers. So if you add these all numbers, you should get 555. Okay. So formula says that x bar sample mean for the group data. So the summation of f times xm is 555 you should get. Okay. But the formula says that x bar is given by the summation f times xm over summation f, right? So this is the formula for the sample mean. So the summation of xm is 555. And I'm dividing that by the number of data values, which is 25. Okay, so I'm going to write this into one decimal place. Why? Because the original data values should be the original data values. If you look at here, the class, remember when you make, right, the frequency distribution table, we had the rule, right? So if you see all the class boundaries are in one decimal place, that means your original row data is going to be 0 decimal place, whole numbers in other words. So my original data values are whole numbers, therefore my X bar should be 1 decimal place answer. Therefore I'm writing 1 decimal place answer here. So if you want, you could use the calculator. So I'm dividing 555 by 25, that is 22.2. Therefore mean sample mean for this group frequency is 22.2. Okay. So now I'm going to show you how to use the calculator, to find these values. Okay. So let me go back from this example and I will show you how to use calculator. Okay. So first, remember, I'm going to do this example. You are given raw data. So enter all the data values into L1 column. So, okay, I'm going to stats, edit, and let me clear this. Okay, I'm going to enter all the data values. So 4, 46, 98, 115, 88, 44, 73, 48, and 62. Okay, so I have 9 data values. Okay, now I'm going to calculate mean X bar, right? So let me write down here the steps. Okay, so I'm going to use the calculator. So first enter all the raw data. Enter all the raw data values into L1 column, right? Then go to stats, go to calc, and use the first one, which is one var stats. That means one variable statistics. So find this number, then hit enter. You will get some, the number summary of your data set, we call it. So I'm following these steps. So after entering the data values, go to stats, calculation, and the number one. You see one var stat. Just enter. You will get bunch of numbers here. This is nothing but the summary of your data set. Now we are looking for a sample mean, which is X bar, right? So if you look at your answer here, X bar, you see, so you have to round up your answer to 1 decimal places, since all the values are 0 decimal places in my raw data. Therefore, my answer is 64.2. Yes, correct. Exactly, we got that answer. So this is very easy, when you enter all the values into calculator. So this is the easiest way. Okay, now I'm going to show you this problem, right? The frequency table problem. Okay. Okay, so here, remember, the formula says that you need to, find the frequency, midpoints, right? Then you need to divide by summation of f. So I'm going to create these two columns in my calculator. Okay. So I need to know the midpoints, right? Then you should know the product of fxn. So let me show that. Okay, so I'm going to clear first this. Okay, so I need to know first the midpoint, right? So find the midpoint first. Find the midpoint. So I already have midpoints here, right? So enter those values. So 18, 23, 28, 33, and 38. So that is my L1 column, right? So let me write down. So I'm using calculator here. Okay, so what is the step? So I'm going to enter all the midpoints, XM. I'm entering into L1 column, right? Then you need to enter all the frequencies into L2 column. So let us do first these two things. So I'm going to enter my all the midpoints already have done. Now I'm going to enter all the frequencies in L2 column. Remember frequency in second column here, right? So that is 13, 6, 4, 1, and 1. So first of all, you need to do these two. Okay. Now I'm going to create the third column, which is f times xm, right? So I should know f times xm. So these values right? I'm going to, put into L3, okay? The easiest way is I'm not going to type one by one. Calculator will, find automatically once you have these two. So that means you move your cursor to L3, highlight the L3. Okay, I'm going to define my L3 column. My L3 column is what? Nothing but the product of F and XM, right? My F is in L2 column and my XM is in L1 column. So simply you need to multiply L1 and L2 to get L3 column, right? Therefore, I'm defining my L3 as what? Simply L1. So L1 is somewhere here, right? So I'm multiplying this with what? L2. So I'm defining my L3 column in terms of L1 and L2. So simply enter. You see now automatically it is populated, right? I did not enter one by one. So this is very easy when you use the calculator. So therefore I have L3 column. That is simply my F times XM. Okay. Now what should I do? Now you need to find X bar, right? Formula says that is, the summation of F times Xm. Then you need to divide the summation of F. Calculator has the function for summation. So calculator use sum. Okay. So there's a function of sum. Remember, I have F times Xm in my L3 column. So simply you find the sum along L3, then divide by sum along what? Frequency. My frequency is in L2 column. So this will give you answer directly. So I'm using these two functions in your calculator. Let's see where it is. So okay. So I'm going to come outside of this. Okay. So I'm coming outside. Right. Now go to second and step. That means basically I'm finding the list. Okay. Now move to math. You find to math. So there you will find sum, right? Okay. So for your explanation, let me write down this step. So whatever I follow here, this is for your explanation. Okay. I just want you to understand. So therefore, I'm writing here. How do you get this guy? Sum L3. Go to second button, right? Press with stats. Then move your cursor to what? To math, right? There you will find the number 5, which is sum, right? That is sum. That means so calculator will use this function as a summation and it will calculate. So follow those steps, right? Okay. So I'm doing those things now, and let's find out then answer. Okay. So I'm going back to my calculator. Okay. So I need to know this sum. Okay, sum of what? Sum of L3. Where's L3? L3 is number 3 with the yellow button, right? Okay, close this button. So that is my numerator piece. Then I need to divide this by, again, you need to go to sum, stats, math. Then number 5 is summation, right? Go to the summation, enter. And my second number is L2. That is second with L2. Okay. So simply enter now. Good. So you got 22.2. Yes, exactly. We got that answer, right? Okay. So that is 22.2. You see now, once you get practice by using calculator, it is very easy. It is very, very effective when you use the calculator. So, do practice. Be familiar with the calculator manipulation. Then you should be good end of this course. I'm going to show you a lot of things, in terms of technology. So you will learn a lot of things during this statistical course. Okay, so that is my main by using the calculator. That's up to you. So you could use either manually or by using calculator when you are asked to do this problem. Okay, good. So this is all about finding mean. Okay, let's move to the second measure, which is the median. The median is the midpoint of the data set. Okay, once you arrange your data set in ascending or descending order, the middle one, the midpoint, of the data set is which is called the median. Okay, so how do you find the median? If you are given a raw data, arrange the data values in ascending order, determine the number of values in the data set. How many data values are given? Ask yourself. If you are given odd number of data values, then the middle number, of course, you will have only one middle number if you are given odd number of data values, which is called the median. If you are given an even number of data values, then you will have obviously two middle numbers. So you need to find the average of those two numbers to find the median. So there are two scenarios. So we will look at one example, then you will understand it clearly. Okay, right. The data show the number of tablet sales in millions of units for a 5-year period. Find the median of the data set. Remember I told you earlier, you need to first rearrange the data set. Okay, so I'm rearranging this data set in ascending order, therefore the smallest to the largest. The smallest, the value is of course 17.6. The next smallest one is going to be 69.8. The next one is 108.2. And the next one is, of course, 159.8. And the last one is 222.6. So I'm arranging in order. How many data values are given? What is my little n here? 1, 2, 3, 4, 5 data values, right? So my data values, number of data values are now 5. Okay, so there are 5 data values. So that means 5 is an odd number, so you will have only one middle number. How do you find that middle number? Simply strike from both ends and you will get the middle number. So this is my middle number, which is median. Okay, therefore, or we use MD as median. Right? So that is 108.2. Again, so you could use the calculator to find the median. So just enter all the data values, sorry, into L1 column. So I'm entering all the data values. So I'm entering all the the given row data without arranging, right? If you use the calculator, you don't need to arrange. Calculator will do automatically everything. So I'm just simply adding the given problem, okay, right away. So my first value is 108.2. Next one is 17.6 and 159.8, 69.8. And 222.6. Okay, after entering all the data values, go to stats, and like we did in finding mean, the same procedure. So go to the calc, number one, var stats. So just click that. So you will get bunch of data values. So scroll down your cursor and you will find the median somewhere. You see MAD. MAD stand for median. So median we got 108.2 exactly. We got the same answer, right? So this is the way to use the calculator. Find the median. Okay. So if you look at next one, that's up to you. So you could use either calculator or do manually. Okay, I'm going to show you manually. So why don't you check by using the calculator whether you can same answer or not. Okay, so how many data values are given? 1, 2, 3, 4, 5, 6, 7, 8. Remember now, 8 is an even number, so you will have two middle numbers. So let us arrange in order first. So which one is the smallest one here? So 656 is the smallest one. The next one is 684. Then 702. Then 764. Then 856. Then what is the smallest number? So 1132. Then 1133. And the last one is 1303. Since I have two middle numbers now, so what are those? Simply strike off both ends. You see now you get two middle numbers. Find the average of these two numbers. Therefore, the median MD is simply the average of these two numbers, 764 plus 856 divided by 2. So if you use the calculator, don't forget to put the parentheses, okay? So what is that number? So let us use the calculator. I'm using the parentheses 764 plus 856, then divide by 2. So you got 810. Okay. So what does mean by that? That means 810 is the the middle position of your data values, right? Remember, I told you earlier, median will divide the complete data set into two equal pieces, right? So your median is somewhere now here, right? So this is my median MD. This side, right? 1, 2, 3, 4. That side also 1, 2, 3, 4. You have equal pieces of data values both in, right? Therefore, 810 will fall somewhere between 764 to 856. Makes sense. But whereas here, so you need to look at that number. This guy is the median now, right? Because this side two numbers and that side two numbers. So that's a way to find median. Okay. Okay. The next one, the last one, is going to be the mode. This is the easiest one. The mod is what? Mod, right? That is my third measure, right? Of average, which is called the mod. Mod is the value that occurs most often in the data set. The number occurring more times, which is going to be mod. Which number occurs more? Ask yourself. That number is going to be mod. You may have one answer, you may have more than one, or you may have nothing. There are several scenarios, right? Okay. So if you read this, a data set that has only one value, if you see only one value, the greatest frequency, then it is a unimodal. If the data set has two values that occurs with the same greatest frequency, both values are now considered to be the mod, which is called the bimodal, because you have two bi, here only one uni. If you have more than two, mod answer, which is called multimodal. Okay, multimodal. Look at next one. When there is no data value occurs more than once, okay, then there's no mod in that problem. So you have to say no mod. You cannot write just zero. You have to write in words. If you cannot find any number which occurs more than once, then it is not going to be mod. Therefore, there's no mod. You are writing clearly. Okay. Yes. Okay. So now look at this example. The data show the number of public libraries in a sample of 8 states. Find the mode. So which number occurs more? So if you want, you could rearrange this and find. Okay. So that's up to you. So 77 occurs 2 times, right? Is there any number occurring more than once? No. So only 77 occurs, 2 times. So this number, occurs more than remaining all numbers. Therefore, mod is going to be 77. It's very easy to find mod. Okay, I will show you a couple of more examples here. Could you find the mod? Find mod. Okay, so look at this one. So could you tell me what is the mod of this problem? 2, 2, 3, 3, 5, 10, and say 12. What is the mod? Okay, so if you look at carefully, 2 occurs 2 times, 3 occurs 2 times, remaining all only 1 time appearing, right? Therefore, 2 and 3 occurs more. These two are having same equal frequency. Therefore, mod is now 2 and 3. So you have now 2 answers, right? Does that make sense? Okay. So now what about this guy? Suppose if you have 2, 2, 3, 3, and 4, 4. Now what is the mod? All three numbers occurs more than once, which is 2 actually. Therefore, all three has the same frequency, which is more than once. Therefore, there's a mod. So here I have multiple mods, 1, 2, 3. All of them are going to be now mod, right? All three numbers are going to be now mod. Okay? But look at this example. Okay, I'm giving number 1, 2, 3, 4. What is the mod? All the numbers occurs, you know, only ones. So you don't find any number which occurs more than once. Therefore, in this case, there is no mod. So this is the real explanation. So all kind of scenarios I have shown here. Okay, so that is finding mod. Okay, there is just simple thing. So now let's move to the mid-range. The mid-range of the data values is simply we denote by MR for mid-range. The mid-range of the data set is simply, the average of lowest and the highest value. Simply add the lowest and the highest, then divide by 2. So which is my mid-range. Okay. Just mean by weighted mean. Suppose if you are given a variable means the attribute or whatever we are interested. For example, look at that. Suppose if I want to consider the marks of the students those scored for my first exam. So the variable is going to be marks there, right? So whatever I'm interested in calculated, that the attribute is called the variable, right? So the variable is simply the data values, right? Variable x means simply here I will have the data value. So we will find the data values there. Okay. So how do you find the weighted mean for the data values, right? So this formula says what? This formula says suppose if x1, this is the data value for particular number, right? Say this number occurs say w1 times. So basically kind of you could think like a frequency, right? Say x2 occurs w2 times and so on, right? Say my last number, say xn occurs wn times, right? Then weighted mean x bar is simply product of these two numbers, like you're multiplying frequency with midpoints, the similar sort of the notion you could think of. So there if you use the group frequency, right? In the group frequency, remember the group frequency, how did you find the mean? Mean was given by the summation f times xm over the summation of f. This formula is similar to that. So simply you change f by w and xm is my data values, right? So this is my data values variable x. So this is my w. So you will come up with the same formula whatever we have, right? But we are giving this different notion for that. Okay, so the weighted mean of the data variable is the x is given by this formula. Okay, you will be given all the weightages. These w's are going to be the weightages of the particular data value. Okay, so in this notation, summation w means what? Summation w means basically you are adding all the weightage, that is w1 plus W2 all the way up to Wn. Okay, so this is the expression of summation or sigma W. Okay, so look at this nice example for finding weightage mean. Okay, so look at this problem. A student received an A in English composition, which composition 1, right, which is 3 credits course, and getting C in introductory to psychology, right? So there is also 3 credit course, and the B in the biology 4 credits, and the D in physical education 2 credits. Assuming that A is the 4 grade point average GPA, say B is 3, say C is 2, and D is 1, F is 0. To find the grade point average for that particular student. So that means if you make a table now, these are the different courses he or she is taking. Now the number of credits for each variable. Now these are going to be my variable, right? The course, the course. These are the variables now. So you could think of, the course marks. You could say, right? Grade in another word. So yeah, that is x here. The course grade is x. Now this is my variable. Okay. So it is given, right? You know the grades for each problem, right? So now remember, my data values are now x1, x2, x3 are 4, 2, 3, 1. So this is my x1, which is 4, my x2 for the second course, which is 2, this value. And my x3 values, the grade x variable value is 3, and x4 is 1. Okay. These all my W's, right? So this is my W1, this is my W2, weightages in other words. This is W3 and this is W4. The question is, what is his GPA in grade point average overall? So that is basically the weighted mean. So the weighted mean is given by this formula. Simply multiply, the weightage with this grade point, and that grade is equal to okay. Simply you are multiplying this 4 times 3 plus 3 times 2 plus 4 times 3 plus 2 times 1 divide by the summation of W. So when you add these all W's, this is my summation W. Simply add these values. So if you find the total of these values is going to be the summation of my weightage, which is 3 plus 3 is 6, 10, 12, right? That is my summation W or sigma W, right? So use the formula and you will find. So the GPA Shioki got is 2.7 overall GPA. Okay, this is the way to calculate GPA. Okay, so now remaining these are kind of the summary whatever I explained you, and you can go through this and try to understand all the properties we could call properties for all three center of measures, right? So mean, median, mode. So the VB, so that mid-range also. Okay, that's it. So I believe you will go through these all three, and if you have any doubt, please let me know. Okay. So here, remember we have already shown about the distribution of the data set, the nature of the distribution of the data set. So if you are given the histogram, so left skewed, right skewed, and the bell shape, those things we looked at in detail. So now here, um, this is you see you have the so many data values after the peak which are falling in right side of the peak. So this is the right skewed, right? So positively skewed or right skewed. So if you look at here, the data set is now going this left side to the peak from the peak. So it's going to be left skewed, and this is kind of symmetric curve, right? So that is why it is symmetry. So this is the catch. If you have the symmetric, the distribution, then mean, median, mode are the same number, right? So mean, median, mode is the peak one, right? The highest one. Okay. So for the symmetric curve, all three values are same. For the right squid, remember the peak, the top of your, the distribution is always going to be mod. Mod is the highest value of your data, right? So remember this all my frequency, right? Highest frequency occurs at this point, so it is going to be mod. Okay. So if you have right squid distribution, that means what? That means mod is the smallest one. Next to one is median, and the highest one is mean. Okay. Remember, median is the middle one. So median is always going to be between mod and mean. Okay. So in some case it may be equal because of this. Maybe equal is possible. Your average mean maybe equals to mod. Oh, sorry, median. Maybe. So now if you look at the right squid, so whenever you have the right squid, that means what? That means mod is the smallest one because that is here. Then median, then mean. Mean is the highest. But this is in another way, right? If it is left squid, then mod is the highest one, right? Then mean is the lowest one. So keep in mind this order. So for the right squid, right? So mod is the smallest one. The next biggest one is median. Then highest one is mean. But for the left squid, mean is the lowest one. The next one is median, then the highest one is mod. You need to memorize these all three. Okay. For the symmetric, mean equals median equals mod. All three values are same. In multiple choice problem, you may be asked, suppose if the given the problem is, let's say, skewed right, then they may ask you, hey, what is the correct answer? Maybe then if it is right skewed, so you have to keep in mind this order, right? Mod is the smallest one and mean is the highest one. Okay, good.